Hi everyone. I'm going to talk to you today about scales of measurement. Okay, first of all, your book describes categorical versus quantitative variables. And they actually have listed the categorical variable as nominal and the quantitative variables as ordinal interval ratio. I'm going to let you know that ordinal can also, and a lot of times, is considered categorical as well. It's kind of in between, so it's a little bit tricky. So first I want to talk about nominal. Okay, nominal means categorical. It's non-numeric. So your favorite breed of dog might be a nominal variable. You look at different breeds of dogs and you would write down the names of these dog breeds, but you can't put them in any specific order that makes conceptual sense. Okay, so these are just nominal. That means like name, right? So numbers can be assigned, but they're really arbitrary. So the order of your list doesn't matter. For example, gender is a nominal variable. So there's several other genders we could include here, but just to be really succinct and simple, I just put male and female. So I could, in my data set, I could label male as 0 and female as 1. So that way I could perform different statistics on them, because typically you want to use numeric values when you're doing statistical analyses. However, I could have just did the opposite and used 0 for female and 1 for male. It doesn't matter which number I assign, it doesn't matter what order they go in. Another example would be if I was conducting an experiment and I had a control group and two different experimental groups. So let's say I'm testing a type of curriculum design on this one class and a different type on another class, and I have a third class that is not getting any additional curriculum. They're just sticking with the basic one that's already in place. So then I would have 0 is my control group, 1 is one of the experimental groups, and 2 is the other experimental group. It doesn't matter what numbers I give these. This is just a grouping variable, okay? So numbers assigned do not matter for the number itself or the order. Group 1 is not better than group 0. All right, moving on, ordinal variables. Now this one's a bit tricky because you can see other people have written it down as, oh, ordinal means categorical, and some in your book, for instance, it mentions ordinal as quantitative. The thing you want to remember though is order does matter. Here's an example that I want to give you of like a non-quantitative variable that still is considered ordinal. So level of education, some high school, I would label that 0, high school diploma as 1, some college 2, associate's degree 3, bachelor's degree 4, master's degree 5, and PhD or professional degree 6. Now you can see the education level goes up as we have these numbers go up, right? So this order is important. However, it really doesn't matter what number I put as long as I have some sort of order that makes sense. But technically, it depends on how I'm using this variable in my analyses, right? So I could label these all different as long as I know which group is assigned to this number. It doesn't really matter. But conceptually, there is an order here. So some high school means less education than a high school diploma, and some college is still more education than a high school diploma. So what's really interesting though is, okay, some high school doesn't necessarily tell you how long the person has been in high school. They might only have 2 weeks left of high school. So just because it says some high school and then a high school diploma, you really don't know how far is in between those two variables. just as you really don't know what some college means versus a 2-year degree, because someone that said some college doesn't technically have a degree, but they still might have been in school longer than a person with the associate's degree. It's just that they technically are ranked in this lower area because they don't have a specific degree. So there's just different things that you need to note when you're looking at your data and you're deciding what data you want to collect. Okay? So another instance of this is actually ordinal, but your book has mentioned it in, let's see, the interval area mentions it as interval. Okay, so there's a lot of disagreement about how this variable or these types of variables should be considered. Technically, Likert items like strongly disagree, disagree, neutral, agree, and strongly agree, technically these are ordinal because we don't really know, as much as we would like to infer that the difference between strongly agree or strongly disagree and disagree would be the same as disagree and neutral. We don't necessarily know that for sure. So technically this is ordinal. However, the way it's used in research is it's used as an interval variable. So it gets a little messy. And the thing I just want you to remember is that ordinal means order and rank. So you can tell there's a specific order that these variables need to be put in. Regardless, sometimes you'll see strongly agree first as number 1, and then it slowly moves up to strongly disagree. But that specific part doesn't matter as much as long as you're consistent. But just know that they have to stay in this specific order because it doesn't really make conceptual sense to put them any other way. But we can tell that 1 to 2 is not always the same as 2 to 3. So strongly disagree to disagree doesn't necessarily, you're not necessarily saying the same thing as you would if you were going from disagree to neutral. All right, I know that's confusing, but just know that ordinal is a little, you have a lot of disagreement on how to use these or what they are in some cases. Okay, so for interval, the order still matters, but the values between these variables are the same. They're equidistant, but there's no true zero. So for example, if you're taking the GRE, which is a standardized test for graduate school, like you took the SAT to get into college. So the GRE, the highest score on the GRE is a 170. So if somebody scored a 160, they actually did do 10 points worse than somebody who scored a 170. And if somebody scored a 150, then they did 10 points worse than someone who scored a 160. So you can compare these. So this value is the same between these numbers. But scoring the lowest possible score on the GRE, which is a 130, does not mean lack of quantitative reasoning for this specific section. This is, I'm just talking about one section. Does not mean lack of reasoning. Therefore, there's no true zero here. Fahrenheit is another example. So 89 degrees would be 1 degree cooler than 90, whereas 90 is 1 degree cooler than 91. So these 1 degree changes are comparable, right? So the intervals are equidistant. However, 0 degrees does not really mean no temperature. All right, there's still 0 degrees. We all know that that doesn't mean that there's lack of temperature. It just is a specific temperature. And we know for Fahrenheit that 0 degrees is very cold. Okay. Now ratio, this still has the same types of qualifications here. Order still matters, the equidistant between values, except there is a true zero. So an example would be weight. So 2 pounds is heavier than 1.5 pounds by a half pound. But 1.5 pounds is heavier than 1 pound by a half pound, and these are equidistant. These 2 half pounds mean the same thing. But 0 pounds actually does mean no weight, right? So length is another example. 0 inches really does mean the absence of length. There's no length at all, right? So I know you think, well, what in the world could have no length? But the point is that measurement scale, 0 means no length, okay? 0 pounds means no weight. So I hope this was a little bit helpful in explaining different scales of measurement. If you have any questions, please don't hesitate to ask. I'm more than willing to talk to you about these different things, and I hope this was helpful.